Hello everyone, welcome back with another tutorial. Uh, Today we would be looking at the Monte Carlo analysis simulation. I'm sure that you have covered the basics required for the qualitative risk analysis and also the quantitative analysis. And we will not be going into details of the distributions, different distributions related to the Monte Carlo simulation, but we'll just have a look at few distributions and try to understand how and what's the tool that we are going to discuss today, and also what are the capabilities it has, and just a brief introduction because there's heaps of other ways of doing these things, the quantitative analysis, but it's just a kind of introduction for us to step into the world of the quantitative risk analysis. Right, so let's look at the tutorial for the day. Now, the tutorial has a context saying that the importance of project management, and there'll always be unavoidable circumstances, right? I mean, we all know that when it comes to, especially when it comes to construction projects, but doesn't really stop there, and it may be applicable to all the other projects. It could be an IT project, it could be electrical project, whatever the project is, there would always be unavoidable circumstances. So I may have mentioned this in the previous tutorial, but as a risk manager or a project manager, we would always prefer to know our risks associated with the project, and the quantitative side of it as well, because it's always good to take a decision on the facts and figures rather than uh, purely dependent on the experience. It's always good to have just to verify your experience, maybe, or for people who are not having experience, just to help yourselves with the decision making, to look at the facts and figures. So this is something we are looking at today as well. um, right, so there's a fantastic video available, a 360 video where you can almost feel you're inside on site, seeing the things which are happening around. So it's quite important for you to get this experience and exposure to see what the real construction world is. For the experienced people, you may have this already, but for the people who are just entering into the this world of construction or civil engineering or whatever the area of specialization you are working on, just to get this the real life experience, just to see things are, how the people behave, how they move, what are the equipments, and what's the conditions that we need to face, right? So please review the video. That will give you a good understanding of what's happening around. And our first question, moving on to the first question. Now the question says the construction management team wishes to get an idea of the possible delays which may occur in the first 4 months of the project, and the following risks are identified to be crucial. And there are 10 risks given, and there's three different durations also provided: best case scenario, most likely, and the worst case scenario. And the question requires us to run a Monte Carlo simulation and to assess the duration of the project with a confidence level of 95%. Right. So the now the question itself says, asks us to run a Monte Carlo simulation. So that's kind of straightforward thing to do. But let's say that is not given to you, then you may need to figure out, if the question just says calculate the project duration with the confidence level of 95%, you should get a hint that we are supposed to run a Monte Carlo simulation, because it's discussing about the confidence levels. and looking at the numbers, it gives us the impression that we need to run a Monte Carlo simulation. Right. So, as I was mentioning earlier on, there are so many tools available to run a Monte Carlo simulation currently. And the program which we are using today is at risk, which is from the same parent company where you used the precision tree for the previous tutorial. So they have the at risk software developed purely as a tool or an add-on to the Excel that runs as to help us to run a Monte Carlo simulation. So what does this at risk the tool does is it simplifies the life for us, and by bringing all the distributions and simulations together as a one simple tool. Having said that, you should also know that we can independently run a Monte Carlo simulation as well um, from the Excel itself. Yes, we can do that. It's not straightforward. You need to come up with so many random variables, and you need to think of a way to run so many number of simulations. But it's possible, and it can be done. The other best method is to use the MATLAB. MATLAB makes it a bit more easier than the Excel itself, because Excel you may need to copy so many different cells to get the required number of simulations. But when it comes to the MATLAB, you have the option of running a simple algorithm to iterate the steps for the required number of simulation steps. And there's few other softwares readily available as well. You can just uh, do some online search and get hold of so many different type of tools available, right? But for our discussion today, we'll be looking at the at-risk software. At-risk is, in fact, quite popular among the industry all around the world, and it's one of the softwares which is widely used as well. So you are lucky enough to get a licensed version through the university. So if you go to the My Access, you may see the at-risk as the first the package or the tool because of the at sign. So yeah, you can just simply click it, and it will ask you to open the Citrix receiver, and you may be ended up with the Excel sheet. Now I have copied and did the table already. So if you are following this video with me, just pause this video here and copy the table from the exercise. This table, it's the same table, just replicate the same thing here, right? And let's move forward. So if you are following me, just pause the video now and copy and come up with the table in the at risk, or the Excel with the at risk, right? You should be able to see the at risk sign at the end of your other tab. So make sure you are in the correct Excel file, and then prepare the table. Right. So I hope you have the table right now. Now, the first step of running a Monte Carlo simulation is we can just go and have a look at the at risk. So at risk itself has so many different tools and functions available, and there's heaps of things you can do. So what we are doing today is just a very simple thing, a very simple and straightforward thing, and we are just using one distribution, right? But there's a lot of area that you can explore, play with, and get a lot of experience. So some of the important things that we are looking at today is this the iteration. So we have the option of defining the number of steps required for the analysis. So Monte Carlo simulation is simply, you know, I'm confident that you know this already, but I'm just repeating this. I may be repeating this. It's a matter of looking at the worst case scenario, the worst possible outcome. Looking at what we are trying to do is we are replicating one single scenario over and over again for 5,000 times, right? So, just as an example, it could be your daily journey to from home to university, right? If you think of that journey and come up with a few risks, right? And let's say the time duration, right? So, one day you would reach your home your uni in a, let's say, 40 minutes, but most likely you may reach the university in 60 minutes or 1 hour, and there could be days which it may lead up to 90 minutes, right? 1.5 hours. Let's assume that hypothesis, right? And what we are trying to do is, now that's the experience you may have from, let's say, for the past week or so. But what we are trying to do is we are looking at this for 5,000 days or 10,000 days, and see what's the time it would take for you to reach the university, right? So that's pretty much something that we are trying to look at, and I hope it makes sense. Right. So, and also there's so many different distributions available. And talking about the distributions, I may need a separate day to talk about all the distributions available. But that's a statistical analysis thing, and that's purely a different topic. So I'm not going to go there and try to explain you why these distributions should be used and what are the differences, what are the usefulness of these things. So I'm not going to do that. But when we have this type of a distribution or a case or a situation where we have three different variations, a best case, most likely, and a worst case, or we also call it a 3 point analysis. So we have basically 3 points. We have the option of selecting two different distributions, the triangular distribution or the PERT distribution. And again, I have to say the same thing. So um, um, I'm not going to explain why you should choose which one, right? We'll just the triangular distribution, as the name it implies, it's a simple triangular distribution. So we are just assigning 3 points, right? Or the other one is the PERT distribution. The PERT is again quite similar to the triangular, but it has a more a better distribution in terms of not a normal distribution, but close to the shape looks better, a smooth curve, rather than where the triangular would be sharp edges with the sharp distribution. So you can either use the triangular distribution or the PERT distribution, but for our analysis today, we will be using the PERT distribution, right? Now, there's different ways of doing this, but what we can assign is now taking into consideration the first risk, the delay in shoring pile construction, and we were given three different durations, right? So we can assign this as equal. We would be using the term risk, and when you type the term risk, this will bring up all the functions available for the at risk. Okay, so we will be using risk, and uh, uh, we would be using the PERT distribution, risk PERT. Okay, right, and we'll be selecting these. Uh, So the risk PERT function needs three figures, right? What's the best case, or the earliest one or the lowest one, and then followed by uh, the most likely one, the median one, and what's the worst case scenario. So right, and it gives us the value of 2.16. So what it simply says is there will be a delay of, there's a chance of getting this amount of time as the delay, right? So what do we need to do is we need to this should be actually total uh, delay. Yeah, right. Okay. So we get this value, and we can just copy down the same equation up to this uh, cell. So we have the PERT values relevant to these individual risks, right? So we haven't run the simulation yet, but it's just giving us the distribution, right? And we have the option of uh, getting the total delay out of each these as well, but you can do it or not do it, doesn't matter. And the total delay we are looking at would be the summation of this, right? So we'll get the summation, just use the Excel function, and to here, right, we have this. Right, okay. Now, another thing we do is when running the Monte Carlo simulation, we need to define an output value, right? Because these are the input values or the distribution values which goes into the simulation, but what we are getting out of the simulation is actually the total delay, right? So we need to define this as the delay. So we can simply select the cell, this cell, and just have a look at what's happening to this the equation of the cell, and we can define it as an output. Just click it, right, and it would ask us a name. So that simply represents what the at risk does. It reads through the title that we have given here and replicate the same thing as the name. So we can use the same thing. Click OK. So it will say the risk output plus the summation, right? So when we run the Monte Carlo simulation, this would be the value we are looking at, right? And but what the question asks us is uh, to calculate the delay with a 95% confidence, right? So we'll go to the delay with 95% confidence, right? Okay. Now, if you have a question about what are these values coming from the distribution, how these numbers came out, you can simply click the settings button, right? Go to settings, and it would tell you that when a simulation is not running, distribution returns what's the value, right, that we are looking at. So it says a static value where risk static is not defined, use exact expected value, right? And we can go for different value. We can go for a percentile, mode, or whatever the value we look for, or we can simply put a random value as well. But for the sake of our analysis, we will leave it as it is, right? So that's what the value represents. Okay. Now, we can run a simulation. Just we can select the number of iterations, so 10,000 iterations, and click the simulate button. So it will run. Right. Okay. Now we can see the simulation, the details of the simulation. Now this is quite important that uh, the graph and what are the statistics available with the graph. So what does it say is the 90% time the values will be land in between 19.75 and 25.78, right? This would be the lowest and the highest point where the 95% of the dates would land in. And now the value which we have received is 22.75, so that basically represents the mean, right? So if you have look at the mean, so that's the mean we have. And if you scroll down further down, then you can have a look at the different values relevant to the different statistics. So what we are interested is the 95% confidence level value, right? So that should be 25.781. um, Now let's see how we can get that value, because from the graph what we are getting is the mean, right? So what how we can get it? So you can simply close it, and if you want to re-look at it, you can just go to results and click this the browse results button, and you can see the output file. Right. So delay with the 95% confidence will be given to you from the function which is the risk per. So let's risk percentile. So we'll say risk percentile, right? Click it, and we need to select what the cell we are looking at and define the confidence level. So we are looking at 95% confidence, so that is 0.95, and then we would be getting a value of 25.78, right? Okay, so that's the value which represented the 95% confidence level as well. So this is how we can run a very basic Monte Carlo simulation for any given question. So this is, as I said, this is a very basic one, and you can explore a lot. There are different settings, and you can when running the Monte Carlo simulations, uh, there is this the syntax we call as the random seed or a static seed. So that represents now the repeatability. Now, if we don't randomize all the values, then we have, if we define a seed, then we would be getting the same set of results over and over again. But I mean, we can repeat it, but it wouldn't change, right? If I run the same thing 10,000 times and ask you to run it for 10,000 times, we would both get the same 95% value, right? Whereas if we randomize this, you would be getting a different value and I will be getting a different value. So that's one thing you should remember. But the at risk takes care of that, but we can randomize it if you want by clicking this button, but that is up to you to do it in a later stage, and for you to understand when you explore a bit more through the at risk. Right, so I hope this was clear to you, and just have a look and play with it. There are so many different videos available online. If you search simply at risk Monte Carlo simulation, just uh, use YouTube. There are so many videos from the manufacturer Palisade, or with from other people as well, but they'll explain you so many different things. But what we wanted to give you is a basic understanding of an introduction to what the at risk is and how we can run a simple Monte Carlo simulation.